Okay. So these first formulas, these are just some of your basic identities. Go ahead and jot them down, and then I'll talk to you about where they come from. I think some of them should be pretty familiar to you. And this is theta. You do need your theta when you write down the formulas. Okay. You're now like day 2 on this? Like you're behind? You're not behind. You're the second day of it. So guys, the first 3 there, cosecant being the reciprocal of sine, 1 over sine. Is this familiar to you guys from before break? Like you remember this? And tangent we knew was y over x. Sine is y, cosine is x. Okay, so is this vaguely familiar to you from before break? All right. Anybody need more time on these? Okay. What we're going to do with these is use them as substitutions in our proof. So that's why I'm having you write them all down. Don't get scared. Start with that. This is called your Pythagorean theorem identity. I'll let you write it down and then I'll show you where it comes from. Okay, guys, you don't have to write this part down. Let me just show you why this works. So let's say we have our circle. If there's a point on our circle, are you guys okay with the coordinates of it would be x and y? Okay. So if I drew in my little right triangle, do you guys understand that that side is x and that side is y. Okay. If I'm on the unit circle, how long is the hypotenuse? What's the radius of the circle? 1. Yes, the unit circle, so it's 1 unit long, so this is 1. So Pythagorean theorem that you've been doing forever would be x squared plus y squared equals 1 squared, right? Okay, from the trig stuff we've been doing, what was represented by x? Cosine, so this is really cosine squared, and we have to have our angle in there. Y was sine, equals 1. Okay, yes, cosine is x, sine is y. That is where that Pythagorean identity comes from. Okay, we can derive some other formulas from this. So this is the first one. You must know this one. All right, a couple of others that we can get from there. If I start with that basic sine squared theta plus cosine squared theta equals 1, and I divide every term by sine squared. So every single term dividing it by sine squared. Let's look at what we have left. What is sine squared divided by sine squared? Okay, that one's not supposed to be the hard one. 1? Okay, good. What do you think cosine squared over sine squared is? Look at what you wrote down from the last page. Yeah. And since they were squared, that makes it cotangent squared. So what do you think 1 over sine squared is going to be? Cosecant squared, yeah. Okay. So that is another formula. All right, let's start again with sine squared plus cosine squared equals 1. What do you think I might want to do this time? Yep, divide by cosine squared. So what is sine squared over cosine squared? Tangent squared. What about cosine squared over cosine squared? 1. 1 over cosine squared? Secant squared. Okay, are you with me on where both of those come from? Okay. We can also move things around. So let's look at, like, the one we just wrote. What if I wanted it to be tangent squared theta equals? Like, how would I get the tangent squared by itself? Subtract 1. So I know tangent squared equals secant squared minus 1. So that's the same formula, just another version of it. So on the left here, if I wanted this to be cotangent squared equals, what would that equal? How would I get it by itself? Yeah, you'd subtract the 1 again. So cosecant squared minus 1. Okay. Let's go back up to the original one. What if I wanted to solve that for sine squared? What would that equal? I know you guys can subtract. 1 minus cosine squared. And one more, what if I wanted to solve for cosine squared? What's that going to equal? 1 minus sine squared. Okay. Do you guys notice how everything is squared in all of these? Okay, that has to be true to use these. If it's just sine plus cosine, that doesn't equal 1. It's like the Pythagorean theorem, your sides would have to be squared, okay? I know these seem very arbitrary to you at this point. What these are is substitutions that are going to make the proofs quicker for you, okay? So we'll do some problems and you'll see how these get used. Right now you just need to note them, okay? Or be able to find them. Questions so far? I know we haven't really done much yet, but a few people still writing. Okay, so all right, we're going to just start some proofs now. So go ahead, write it down. If you don't want to use a beta, if you'd rather use a theta, that's fine. Just so you know, some of the Greek letters we'll use theta. We use beta. Sometimes you'll see alpha. So just write it down and then wait. Maria, you good? Okay. Just checking. All right, so there's kind of some rules with the formatting and the way you have to do your proof. So you're always going to work vertically down your proof, okay? You have to show all of your work. I don't check the last step of your proof. I check all the work along the way. You guys could all have a different way to get to the end, and you could all be correct. So very fun for me to grade. Some of them are very straightforward. Some of them, there's just lots of different routes you can get to the end. And because we're proving this, your properties of equality don't work. So you know how you, when you're solving an equation, how you could, you know, multiply both sides by 2 or subtract something from both sides. You can't ever cross the equal sign here. So we're going to draw a big line right down there. You can simplify on one side and you can simplify on the other side. And the whole goal is just to make the two sides equal to each other. Okay? All right, so let's just go through some of these so you can see what it's supposed to look like. So the first one here, the left side, there's not a lot to do because it's just cosine. But on the right side, is there a substitution I could use for cotangent? Cosine over sine, yes. So this is going to be cosine of beta over sine of beta. And then this just means times sine of beta, like it's just next to it, so it's multiplication. So knowing what you know about fractions, can I get rid of anything now? Yeah, sine of beta is going to cancel out. So what am I left with on this side? Cosine of beta. And isn't that what I had on the other side? Okay. You have done your first proof. Isn't that better than geometry? Maybe? Yes. All right, so again, what I'm talking about there, you work vertically down the page. Everything's nice and neat. And yes, you have to write the beta or the theta, whatever we're using, in every step. Okay? Don't make me be mean. It does look like a fish. It's alpha. Okay. I had a kid one year when we started doing that. He just kept drawing them and like made little fit. Like he had a whole little school of fish going on his paper. Not a lot of proofs happening for him, but he had some good pictures. All right, so are we okay with the first one? Okay, let's try. Do you guys want to try? Are we feeling brave? The sit and stare approach is not real effective. So always try something. If it doesn't work out, that's okay. I think sometimes you guys are very afraid of being wrong. You're like, I'd try something and then any idea what to try? Okay, yep. Can you substitute for cotangent? So that's what's fun. Yeah. Oh, yeah.
I just like split this with bars.
So that's not actually the same because that would be sine times cosine over, or sorry, sine times cotangent over cosine squared. If there had been a plus in between, you're saying yes, or cotangent. So it's all multiplication. So. That's fine. Yeah. Yeah.
This one you can.
Guys, if you have any like weaknesses with your algebra skills with fractions, those may come to light and we will work to improve on those. If you're scared of fractions, we'll get through it. Okay. Yeah. Okay, and then your next step. Yeah, just you've got to write things here and then no magic.
Does that work? I feel like it's like weird if learn into secant and then like that little
Extra.
Okay.
And you would want to rewrite the secant times sine and all that stuff. Okay. Or you could really just write it as like sine. Yep. All right, guys. Let's go here to see. So guys, a couple different ways you can do this. I saw some of you kind of split this and said this was sine over cosine times cotangent. Does everybody understand that that is the same as what the original step is? Okay. And then cotangent is just cosine over sine. Okay. That's all going to cancel. Then you have 1 equals 1. Some of you here turned this into tangent and just said tangent times cotangent is 1. That's okay. Yeah, that works. Some of you, let me do another one over here, wrote it as sine times cosine over cosine. And then just did like a 2-part reducing. And then got to 1. That's fine. Okay. So lots of little variances in how you could do this. Walking around, it looked like a lot of you got there. How are we doing so far? Okay. All right. Let's try again. No cheating. This is one where you might want to work on both sides. You still can't cross over, but you can simplify on both sides. How we doing, guys? Yeah, okay. Okay, guys, talk to someone around you, compare, see if you agree. I hear a lot of 1 equals 1. Yes, okay. It's not always going to be 1 equals 1 at the end. Okay. All right, let's go through this just to make sure. So we know cosecant is 1 over sine, right? So I get a 1 over here. I get a 1 over here. We like that one? Yes? Okay. Feeling good, right? Okay. What number am I on? 4? All right, this one isn't just all multiplication. You've got a little bit more happening, but it's not bad. So I'll give you a second, write that down. Look for substitutions, guys. Guys, look, I see a sine squared, so that makes me think maybe a Pythagorean identity is where I want to go. So look back at your Pythagorean identities. See if there's a substitution you could use. Not usually like secant and cosecant. Very equal. You're like, oh no, what do I do? So I'm thinking you're the kid. It's going to take like to get next to where you're trying to like,
And then we got it. Like really obvious. That's why I was kind of doing it, but I don't know if the school and
okay. You really like secants here. Maddie, you're not alone.
I know it's something for like
Angry erasing, that's okay. So, oh, I can like I know I don't really.
no, it was Ben.
And you like define that's fine, yeah.
I don't know what I'm doing.
How are we doing, guys?
I don't know how to do it. I just don't have something to do with this.
It has something to do with that, okay.
I have to
Okay.
so I'm like having this and I
You can do that in a more complicated way. Wait. And then it's minus.
my mom got it. She was like super like during the summer.
No, it's all closer. And then what's that?
My mom's got me like years.
You know, show what I X squared over X.
One day she got one of them filled up with water.
Yes.
Probably
Which is we're trying to. But I'll show you this before. Like, that way it works, but it's a little easier. Okay. Look. Ready? Okay, guys. So the Pythagorean substitution you want to use, if you wrote them down, back here somewhere. Look right here. What does 1 minus sine squared equal? cosine squared. So I'm going to replace the 1 minus sine squared with cosine squared. Okay, now some of you got here and then were like, I don't know what that means and I don't know where to go. You're back to just algebra concepts now. If I had x squared over x, what would that be? Yeah, that's x times x over x, which is really just x, right? So what do you think cosine squared over cosine is going to be? Cosine, yes. Okay, guys, make sure you're aware of what's on the left side of the equation, because you're done then, okay? Cosine equals cosine, they match. You don't have to do anything else, okay? Questions? Are we okay with the very first step? Like, do you see the Pythagorean substitution? Yeah, go ahead.
So where does the sine go?
Okay, so remember our identity. So this is what we started with, right? And then this is one of the ones we can manipulate that into. So the entire thing, 1 minus sine squared, is equal to cosine squared. So I can replace all of that with just cosine squared. That's what I mean by substituting, is you're replacing that entire piece with whatever it's equal to. Okay. And there are other longer ways to get there. You could have made different substitutions, but that's the easiest way to get there. Okay.
So you can just like ignore the cosine under the...
Well, it's still there. Yeah, it doesn't go anywhere. And guys, that's another thing with your proofs. Make sure that pieces of it don't disappear and then reappear later, okay? That we can't have magic happening. It's gotta just, it's all there the whole way through, okay? It takes practice. There's lots of details with it. All right, let's try it again. All right. Give you guys a minute to try this one. Again, feel free to work on both sides, just can't cross over.
Yeah.
Okay, guys, some of you are going to end this one with cotangent equals cotangent. Some are going to end with cosine over sine equals cosine over sine. That's fine. You could have 1 over tangent equals 1 over tangent.
So I got
That might be a bad answer.
No, I got the first one that you said.
Okay.
I don't know what to do with this.
Okay, so what time is it? And then it's still times cosine.
My mom stressed me.
So that's cosine over sine. So if you have right? That's what that is. Because this is technically over 1.
Yeah.
When fractions equal. And then what is cosine over sine? There. All right, let's go through it. All right, guys. It looks like most of you started with 1 over tangent is cotangent. That's good. Okay. And then on this side, cosecant is 1 over sine. So over here, I now have cosine over sine. And what is cosine over sine? Cotangent. So you could either make both sides into cotangent, or you could have made both sides into cosine over sine. Okay? Not bad? Okay. All right, we're about to jump to one that is much harder, okay? All right, guys, this one has a lot happening in it. There's substitutions you need to do. There's factoring you need to do. There's common denominators you need to find. So, I'm going to give you some time to try. Let's see where you can get what you can accomplish. But this one should be hard. Like, this is not a simple proof. Just remember, guys, we are spending 3 full days on this, okay? I'm going to give you like where you should end up. See if I can do it right in my head. Yep. That's where you're going to end up, is 1 minus cosine over 1 plus.
You would set my feet in like the baby pool and then you just chucked me off the high dive.
Yep. I'll throw you a pool noodle, don't worry. Okay. And guys, remember, if you're not sure what the whole path is, that's okay. Start somewhere. Look at it and go, well, sine squared. I could substitute something for that. Okay? Like I see in my answers, I'm going to end up with cosine. So maybe I want to turn sine squared into something that has cosines in it. Okay? You have to factor on the left side You have to do common denominators on the right side. So there's a lot happening here. And all of that starts with some substitutions. So if you're not sure about the factoring or any of that, start with the substitutions. What could I turn sine squared into? What is cosecant? What is cotangent? Rewrite all of those, okay? Are you like doggy paddling in the deep end now? Is that where we are? Exactly. How's the struggle? Like, I like what you're thinking. But, like, there'd be like one. Yeah. Yeah, so it was actually, like, yeah, this 100 bus just going away. And then, they're over pluses. Oh. Okay. So you're sort of breaking the law, right? When you're reducing a fraction, you can only cancel out factors, not terms. So I had like I would check for it and I'd be like, no. What if I had so like you're laughing at me like this. So 1 over 7 is yeah. It's the same as 4 over 11. The only way to cross the bus is actually a vector. So if you had like 1 plus that's why I said wait, vector. I got 1. Keep talking to each other, guys. I promise I will very close. We both on the right side? 1 over sine minus cosine. If you look at it, both on the I'm getting something. So it's just 1 minus cosine. Oh, because we're falling. But it's not. Okay. It's just not even on. Oh. You should do like 1 over like 1 minus cosine. But it's just 1 minus 1.
I have a
Okay, I like this.
The last one, I thought was always yeah, but I have a one where yeah.
Oh,
On the bottom. Like I have one plus.
that's so weird.
Because there's a one plus in front of it up there. Well, I just expected like if it was one plus like squares. So I can't say one
Okay. Turn it on. And you're gonna see sort of.
No, I just, okay. It's obviously like factor it, and it's like, cosine minus one.
Because it was science fair. So that fact, that numerator.
Oh, so now I'm looking at it.
Right, right.
So this side.
Oh, okay. Did you break some laws here? Okay. So I would rewrite it here. Okay. All right, guys, let me go through it up here. You guys are doing good, though. There's lots of good stuff happening. I think the left side is harder than the right side for you guys, just because it's weird for you to think about factoring with sine and cosine. No, Sean, you disagree? Did you get the right side? Did you turn it into the sines and cosine? Okay. We'll start over here on the right. So guys, cosecant is just 1 over sine, right? And cotangent is cosine over sine. All of that is over 1 over sine plus cosine over sine. Does that make sense? Okay. Guys, this is an approach. If you look at a problem and you have absolutely no idea where to go, turn everything into sines and cosines and see if that does anything for you, okay? So if you're stuck, try that. Do you notice how I have common denominators already for my fractions in the numerator and fractions in the denominator? Okay. So this is really 1 minus cosine all over sine over 1 plus cosine all over sine. Okay, something that I realized my 6th period didn't remember very well. If you have a fraction divided by another fraction, what do you do? Okay, yeah, so flip and multiply. So this is really 2/3 times 6 over 5. Yeah, okay, that's what we're going to do here as well. Move this guy down a little. Yay. So this is really 1 minus cosine over sine times, I'm going to flip and multiply, so sine over 1 plus cosine. We're okay with that? What happens there then? They cancel, right? Okay, so now I have 1 minus cosine over 1 plus cosine. Okay? All right, so that is the right side. How do we feel about that? You guys see what I mean? How your like algebra skills with fractions and understanding common denominators and all of that, like that's going to be pretty important in these. Okay, the left side. All right, I notice then I have a whole bunch of cosines going on, and then this one random sign in my numerator. So I would like that to not be a sign anymore. So sine squared is 1 minus cosine squared. Okay, so that's one step, just replacing that. I now have to factor. Do you guys remember how to factor difference of squares? Okay, so let's think back to algebra stuff. If I had x squared minus 9, what does that factor into? Okay, it's minus 3x plus 3. Yes? Vaguely familiar? Okay. So, 1 minus cosine squared, what is that going to be? Yeah, 1 minus cosine, 1 plus cosine. Okay. All right. The denominator there. That is 1 plus 2 cosine theta plus cosine squared theta. So again, algebra world, if I had 1 plus 2x plus x squared, could you factor that? Okay. Isn't that just 1 plus x times 1 plus x? Okay, so for our problem, what is it going to be? Because I don't have x's, I have cosines. It's 1 plus cosine times 1 plus cosine. If you are weak at factoring, please come and see me in Warhawk so we can do more practice with factoring, because it's going to show up a lot in your proofs. Okay. Now, what can I get rid of? Yep, and then I am to the 1 minus cosine over 1 plus cosine. Okay? Questions? Did anybody, like, truly get it all the way there? I know a couple of you, as I walked around, I saw you did. How many of you got one side? Okay, that's good, that's good. Okay. That is the end of your notes. We're going to do some classwork for a little bit here, but that is the end of notes.